Welcome to Honors Geometry 11, section 11.6, area of regular polygons, where we finally find something that might challenge you. Alright, let's move along. Okay, a regular polygon, in this case, it is a regular triangle. Some definitions that we need to cover. This distance right here, that is called the radius of the regular polygon. It's drawn from the center of the polygon to a vertex. But hold on a minute, how could that be a center of the regular polygon? Well, actually, it is the center of the circle that circumscribes the regular polygon, and that's why it's a radius. Okay. So, what is the measure of this central angle? Whoops. I turned my marker off, didn't I? I did. What's the measure of this central angle? Okay. The measure of that central angle is, well, there would be three central angles that are all about the same size. If you drew all three central angles, they'd all be the same size. 360 divided by 3, each one of these central angles is 120 degrees. Okay, how about on this regular pentagon? What would this central angle be? That central angle would be 360 divided by 5, 72 degrees. Oh, hey, I forgot to tell you about another term on regular polygons, and that is the apothem. The apothem is the distance from the center to one of the sides. So it's like an altitude of that triangle there, and that A can stand for altitude, it can stand for apothem, and it can also stand for the adjacent side on this right triangle. When we look at, when you drop an altitude on an isosceles triangle, you're going to bisect that angle. So we said this was 72 degrees, but if we bisect it, 36 degrees. And we might need to use trig on that to find out how big the apothem is, depending on the setup. Yeah, I did say trig, sorry. Okay, what's the measure of this central angle of this regular hexagon? 360 divided by 6. Each of these angles is 60 degrees, and of course when you drop that apothem down, it's going to bisect that 60 degree angle, and each half will be 30 degrees. And we're going to need to use that possibly to find the area of a regular hexagon, and we'll move on. Okay, let's review the trig. Okay, we might, if you're given the radius of the regular polygon, you're going to have to find this and this in order to find the area. And let's see if we can remember what that memory device was for trig. Yeah, that's right, it was SOHCAHTOA, I remember now. So looking at the 22.5 degree angle, the A is the adjacent side and the 12 is hypotenuse. Cosine, so the cosine of that 22.5 degree angle equals A over 12. And then looking at that 22.5, the x is the opposite and the 12 is the hypotenuse. Opposite and hypotenuse, that would be sine. So the sine of that 22.5 degree angle equals x over 12. And we'll find both the apothem and a partial side length. and that will help us find the area of the regular polygon. Moving along. Okay, let's do one more. If you're given the length of one side, well, then it's a little bit easier. Hey, this is a 30, 60, 90 triangle. We don't even need to use trig on this. We can just use what our knowledge of 30, 60, 90 triangles. To go from the shorter leg to the longer leg, of course, multiply by root 3. So the apothem would be 12 root 3. And if you really wanted to do the tangent of 30 equals 12 over A equals 12 divided by tangent of 30. If you really wanted to do that, I'm pretty certain you would get the same answer as 12 root 3. If you want to go the long way, hey, that's okay with me. It's just you got to do it the long way. Alright, I think we're good. Let's go ahead and move on and show you what's going on with the area of a regular polygon. So, the area of a regular polygon is A equals 1/2 AP, where A is the apothem and P is the perimeter of the regular polygon. So, here we go. I have a regular octagon ready to go for you guys. And I've given you the radius. So, area equals 1/2 the apothem times the perimeter. Wow. I've not given you the apothem right here, nor have I given you the length of one side. So when you find the x down here, you are going to have to do some trig. Alright, so this central angle, 360 divided by 8, 45 degrees. But remember, when we drop that apothem, we're going to bisect that. So this is going to be 22.5. So the cosine of the 22.5 degree angle equals A over 8. Boy, didn't we just kind of do this? Yeah, kind of. The sine of the 22.5 degree angle equals x over 8. Alright, let me get a calculator and compute those two values, and you do the same thing, and we'll be right back. Alright, so the apothem is approximately 7.3139104, and the x value is 3.06147. So now we can almost find the area. So the area equals 1/2 times 7.39104. We go out to 5 places. We should get close enough. Now, this x, is this the perimeter? No, it's only half of one side. And there are 8 sides, so what we need to do is take this number and multiply by 2, and then by 8, or just multiply by 16. And when we multiply that by 16, we get, sorry, calculator again, that perimeter was around somewhere around 48.98348. So that makes the area equal to 181 point, let's just go out to 2 places on that, 0.02 square centimeters. Wow, that's intense, that's crazy, and yeah, sorry, that's the way life is sometimes. Alright, here you go. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a regular nonagon. This time I've given you the radius. Again, you're going to have to find the apothem and half a side. Okay, 360 divided by 9 is 40, but you're bisecting it, so that's 20 degrees. So the cosine of that 20 degrees equals A over 6, and the sine of that 20 degree angle equals x over 6. So let's go ahead and find A and X and come back and make sure you get the right answers. So the apothem is 5.63816. That's an 8. Hello. Look on your calculator. The X value is 2.05212. So now we're almost ready to find the area of that regular nonagon. The area equals 1/2 times the apothem times the perimeter. This is half of one side. So let's see here, to make it a whole side, multiply by 2 and then multiply by 9, or just take that and multiply by 18. Okay, the perimeter was 36.93818, and then when you multiply those three values together, rounded to two places, 104.13 centimeters squared. And we'll go down to, no, we're going to stop right there. So finding the area of a regular regular polygon can be difficult. It's really nice when they give you the length of one of the sides, because then you can find the perimeter really easy. You know what? Let's go ahead and do that. I'll give you a little bit easier one. This time we have a regular 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A regular decagon. So I've given you the length of one side so you can find the perimeter fairly easy. 10 times 8. So the perimeter is, yeah, that's right, 80. Okay, the measure of this central angle, 360 divided by 10, 36, but when you drop that apothem down, you're going to bisect the angle, so that's an 18-degree angle right in there. And when you drop that apothem down, you also bisect the base, so each half is 4. So let's see here, opposite is 4, adjacent is A, tangent, right? So the tangent of that 18-degree angle equals 4 over A. Switch spots on that. 4 divided by the tangent of 18. The apothem equals, so the apothem is 12.31073. Now I think we're ready to find the area. Area equals 1/2 of that apothem times the perimeter 80, and we should get an answer of 492.43 centimeters squared. Yeah, the best way for you to get better at doing these is by doing them. That's why you will have time to get them done in class. And you can ask all kinds of questions. This will conclude Honors Geometry 11.6, Area of Regular Polygons.